right, guys, are there any questions on any of the assignments thus far? Any questions over 6.1 or 6.2 before we start 6.31? So, what we're starting today and what we're looking at today is logarithms. So we're actually starting on logarithms. Now, logarithms are the inverse of our exponential functions. So a logarithm is the inverse function of an exponential. Now, log base b of y equals x if and only if b to the x is equal to y. So log base b of x, make sure y, because the x and y really don't make a difference, but I want to make sure that I'm keeping it the same as this here, as b to the x is equal to y. If and only if. So one implies the other. So if this is true, then this is true, and if this is true, then this is true. It's a bijectional statement. Bijection. So if the first is true, then the second. Both have to be true for these to work. And these come up a lot in equations of lines and just different proof statements. And it's also the symbolization of if and only if. Yes. Because this is then, if this, then that. So this is kind of saying it's implying it both directions. So, and log base b of y is read as log base b of whatever we have, so y. Now, what we're doing first is we are taking these from logarithmic form and rewriting them as exponential form. We're taking them from logarithmic form and rewriting them in exponential form. So if we look at the first one here, log base 2 of 16 equals 4. Well, 2 is taking the place of b. 16 is in our place where y is, and 4 is where x is. So in the general equation, log base b of y equals x. In this one, b is where 2 is, y is where 16, and x is where 4 is. Because that's just matching it up to our general equation. Yes. And that's all we need to do to rewrite an exponential form. Now, in exponential form, here, we can actually check this. 2 to the 4th equals 16. Because I can grab a calculator and say 2 to the 4th and hit enter. And it tells me that it is indeed 16. So when we have these where we're rewriting them where it's all numbers, we can check, see what 2 to the 4th is. If indeed it is 16, then we have it written correctly. So log base 2 of 16 equals 4. We can rewrite it as 2 to the 4th equals 16. Now in the second one here, b is where, 4 is where b would be, 1 is where y is, and 0 is where x is. Now if I want to rewrite this one in exponential form, we would have what? 4 to the 0 equals 1. And that's it. Questions on this here? Let's look at the next one here. Log base 12 of 12 equals 1. If we rewrote this in exponential form, we would have what? 12 to the 1st equals 12. 12 to the 1 equals 12. How about log base 1/4 of 4 equals -1? 1/4 to the -1 equals 4. Whenever we have a fraction to an exponent, it's good to put parentheses around it, just so we know that that exponent is put to both the numerator and denominator. Questions on this so far? Okay, I'd have to get an extra one. Seems we're one short. Okay. What is that one behind you, Cadence? Okay, I'll have to get an extra one at some point. Sorry about that. Luckily for most of these here, they're not that bad. So the big thing I would have for certain is, let's go to the previous page, log base b of y equals x if and only if b to the x is equal to y. This is the big concept that we're covering at this point. I did this yesterday. Okay, so let's look at these three here. So when we rewrite this one from logarithmic to exponential, we would have 6 to the third equals 216. How about the next one? So Rachel, as I said with these here, what's nice with these here, that just to make sure we got it correctly, we can actually type these in. Get a highlighter. Like with the first one, like I can plug 6 to the third into the calculator, hit enter, and see, does it indeed equal 216? And when we have just pure numbers, not that part, these, we can type these in and check it. Where it kind of falls apart is if for some reason we had a variable. So they wanted us to rewrite log base 7 of x is equal to 4. So how would we rewrite this one? So this one here we can't necessarily check in a calculator because it doesn't actually tell us what it's equal to. It would just be whatever 7 to the 4th is. Any questions on this here before we look at the next part? The next one, we're going the other way around. This time they gave us it in exponential form, and we want to take it back to logarithmic. Yep. So, guys, so we would have log what? Base 5 of what? Is it equal? 2. And that's it. That's all we have to do to rewrite it back in exponential form. What would we do for the next one? Log of what? Of is equal to. And that's it. Any questions on these here so far? Let's look at the next one. 8 to the 2/3 equals 4. So we would have log of 4 is equal to. So log base what? Of 1 over 216 is equal to -3. Any questions on this here? We'll look at 4 more and then we'll move on. 9 squared equals 81 would be log of is equal to 2. The next one would be log base of 0.5 or 0.05 equals, yeah. So log of equals, and lastly, log base of 5 equals -2. Any questions on these here? We ready for what's next? Evaluate. We want to evaluate log base 4 of 64. Now at this point here in this class, we haven't gone over how to actually solve this or kind of type these into a calculator. We will be able to eventually, but what I'm going to do is set it equal to x. And again, x is just an unknown, something we're trying to solve for. Now, let's rewrite this as an exponential. So what would this be as an exponential? 4 to the equals. So we're trying to see here, 4 to what power is 64? So 4 to the 4th is 256. So 4 to the 3rd is 64. So here, when we're trying to see 4 to what power 64, our answer is 3. So log base 4 of 64 is 3. Okay. Let's look at the next one. So we have log base 5 of 0.2, and we'll say it's equal to x. Equals 0.2. Now this might be a little difficult to see in this form. Let's change 0.2 from a decimal to a fraction. Be 1/5. So now we're trying to see what power will take 5 to 1/5. Negatives, yes, because whenever an exponent's negative, to make it positive, we move it from the numerator to denominator or denominator to the, yes. Because since the 5 didn't change, the only thing that changed was moving from the top to the bottom. It's just going to be -1. Because we could have rewritten this as 5 to the x equals 5 to the -1 to bring it back up. So x is going to be -1. Log base 36 of 6. So we could rewrite this as what? 36 to the this one here, I think, is one of the more challenging out of the ones we've done so far. It's close. Yes. It is. Because 1/2, 36 to the 1/2, because our rational exponents, how would we rewrite this? This would be the same as what? Because remember back to the nth root of a to the x is the same as a to the x over n. So our fractional exponents are the same as our radicals. So if we're getting smaller, we're going to be looking at a fraction, because 36 to the 1/2 is the same as the square root of 36, which would give us 6. So it is indeed 1/2. Questions on this here? Not too many more. Any questions on D before we look at C? So C here, so if I rewrote log base 1/5 of 125 as an exponential, we would have what? Now, as we've seen a few times already, if we're going from a fraction to a whole number or a whole number to fraction, we know whatever the exponent is has to be what? Negative, because if we have a negative exponent, it means we have to move it from the numerator to denominator or denominator to numerator. We have to flip it to take it from being negative to positive. Because here, if I move the 5 up, we're saying 5 to the negative x, because 1/5 and 5 to the negative x would be the same, and we're looking at 125. Now we just need to see how many times do I need to multiply 5 by itself to get to 125. Well, 5 times 5 is times 5.
More than once.
So 3. So here it would be negative 3. So log of 1/5, log base 1/5 of 125 is negative 3. Yeah, so we'd multiply 5 3 times. Questions on this here? Let's look at 4 more of these and then we'll move on to the last part of this lesson. So we're looking at this next one, log base 4 of 256. We can set it equal to what? So we're saying 4 to what power is 256? So x would be 4. Well, as we looked at 4 to the 4th already, which is 256. So 4 multiplied by itself 4 times is 256. Any questions on A before we look at B? So if we look at B, set this equal to x. So we're saying 8 to the x is equal to 0.125. It would be good to turn 0.125 into a fraction. And this is going to be 1 over what? Actually works out to be 1 over 8. So what would x be this time? X would be negative 1. Any questions on this so far before we look at C? Now for C, again, when we rewrite it in exponential form, we'd have 1/3 to the x equals, yes, because 3 to the 3rd would be 27, and since we're going from a fraction to a whole number, it would be negative. Let's look at the last one. Here we're going to have 64 to the x is equal to 8. Yes. Because 8 squared is 64, so the square root of 8, or square root of 64 would be 8. And we rewrite square roots as fractional exponents. Any questions on any of this here? All right. Are we ready for the next part? Yeah, I forgot about these. But natural logs are going to be before we finish this up. Now, the natural log, ln of x equals y, if and only if e to the y is equal to x. Now, we don't write this in, but the base for natural logs is understood to be e. It's understood to be e. So ln base e of x equals y is the same as saying the natural log of x is equal to y. So what we're going to do for these next few here is the same as what we did at the beginning, but now we're talking about natural logs instead of logs. So if I want to write ln of 6 equals x as an exponential, we would have what? E to the x equals 6, because ln of x equals y, if and only if e to the y is equal to x. So how about the natural log of 5a equals b would be what? E to the b is equal to 5a. Yes. Any questions on any of this here? Yeah, because we're just rewriting it in an exponential form. Let's look at the next two. The natural log of 42 is equal to b. How would we rewrite this one? Guys, let's focus up here. E to the what? The natural log of z equals 6 is equal to. And with all these here, e is not written in. We don't have to write e in. Let's look at two more. So the natural log of 4 to the y equals d. So we would have what? E to the d equals 4 to the y. E to 3 to the a. E to the e equals 3 to the a. Questions on these here? Let's go the other way around for a few of these here. E to the 9 equals x. How would we? So the natural log ln
X equals E9. Oh, equals 9. My bad.
because our base for this would be
Yeah, L N E. Yeah, I got it. We got a.
now since e is understood for natural logs, we don't have to write that base. Now the next one, e to the 4a equals c. Would,
LNC equals 4A.
yep. And that's it. So for these here, we don't have to write the e back in since it's understood. Yeah. Any questions on this here?
I do not have a question, sir.
E to the 2x equals y.
LN of Y.
ln of y equals 2x.
E to the C equals 57.
So e to the
E. LN equals 57. I thought we didn't have to write in there. Oh, that's my bad.
we don't have to write the e in, but we'll still have to write the z. Any other questions on these here? So I'll go on and do these just to finish this out. So here we would have ln of, and lastly ln of, and this here is the last part. So the first thing we want to do with this here is evaluate log of 8 using a calculator and round to 3 decimal places. So if we want to do this here, we can just grab the calculator. We're going to hit log of 8 and hit enter. And log of 8 is 0.90308. And if we're going to 3 decimal places,
I'll learn how to do this. Doesn't matter if that data is sent for
let's see. No, as long as we don't have something after it, because if we're looking at, say, log of 8 in parentheses minus 4, then it'll make a difference. Because, say, log of 8 minus 4 would give us this. And if we do log of 8 minus 4 without the parentheses, it'll give us a different value because the second one is seeing 8 minus 4 and doing that first. Where on the first one, we wanted to take the value of log of 8 and then subtract 4 from that. So there's a difference between those. So log of 8. So we're taking the logarithmic function of and finding its value at 8. So the natural log of 0.3, so we can grab the calculator and say natural log of 0.3. Either one. Negative 1.204. So we can take this one here, ln of 0.3, and get negative 1.2039, so negative 1.204. That's it. So on these here, we're just using the calculator. So we can do the same thing with these here. And if we type this in, I believe we get 1.991. Log of 98, 1.991. And if we do the same thing for log of 0 or 0.98, we get 0.991. So on these here, we just have to type these into the calculator, and they'll give us the answer. Question on these here. And the last two on the note sheet, again, taking ln of 7.84, 2.059. And we do the same thing for, yeah. Yeah, for these here, we're just typing it straight into the calculator and letting it calculate it for us. Because unlike the ones we did previously, these here aren't going to have nice values for them, especially natural logs, because the base is an irrational number. Any questions on any of this here? And that's it.